BluntCut MetalWorks, June 19, 2021. This is 20 CV with the same composition as M390 at 64 Rockwell. Sharpening using edgepro at 7.5 degree psi, which is straight razor edge. The thickness behind the edge is 15 thou. You can see the bevel really wide. Sharpening here because again at 7.5 degree psi sharpening. That's why you end up you see this drastic big bevel. But however, the edge again is a straight razor, and I will test and you see the edge was finished at about 1000 grit, and then I deburred it with using DMT extra fine. They're little minor, I mean tiny micro or about a few micron imperfection here, or in other words, it's a hole. But with this old thin phone book paper, I will cut until it snags. And so to start out, I'm just going to do, well, I guess we'll do the half-inch scissor rope here. And I got temporary handle, and this is the old profile here. And I'm going to here. So I make about 30 cut or so. I don't expect anticipate that any damage yet from it. So this is some really soft wood, and I'm going to do the shimmer area. I'm going to wither it where the V is, I guess that's where this cut in muscle thing. Right? I'm doing a fairly controlled push, so not that much lateral, except now I just go into the wood, very soft wood. So it's not like and so now I'm going to do a quick test. At the end of the video I will do the close-up of the edge. Disposable bamboo chopstick where near the V is. At this point in testing, I am very fairly controlled here. And yeah, bamboo have a lot of silicate, so yeah, it will do the edge. But right now I'm looking at in order to cut the bamboo, whether all the edge damage occur. And I think I can see quite a bit of rippling going on. And that's important. I want to see what the failure mode is. Again, what all these tests is, I want to see the failure mode. And so I can actually see it. I don't know if you see it under the thing, as you can see right there. Anyway, I can see a lot of ripple, but which is good because it's not chipping. Anyway, there you go. You can see it hesitate. Well, in the area of interest, it hesitates just a little bit. It's right there. I can see it. All right. I mean, that's what this test's for. And in the same area, when you compound, when the edge already folded over, now you compound it. It will bend way too much, then piece of it will fracture. So you cannot continue to roll because the edge is too thin. And so they don't yet get a blunting effect. We have a rolling effect, and then when it roll over and then finally mushroom out, and then it comes fall off. So I'm going to compound that. Right here, this is argentine lignum vitae. And anyway, it's a very dense and hard wood. Because of the edge thinness, it probably will continue to be able to cut the wood, but the damage right now is probably going to be some damage. What was a roll before now is possibly be I will cut way out here to get as a reference, so that later on I can take a picture of what cut in argentine lignum vitae to the edge. The objective is seeing what when you whittle, the edge have to penetrate, and that means the upward push the edge to go up, but you force it downward. So in other words, it bends like this when you enter. So yeah. So now I'm going to did I test? It will hesitate and catch right there, but it comes through because again the thing's small enough so that it won't tear the paper, and this is very thin old phone book paper. And I'm going to this is pork rib bone. This is come to ridiculous. Again, this is a straight razor edge. It's for shaving level thing, not try to shave off. I'm going to go toward where the between the 0 and the C is, and also okay. Let me hold it like this so I can. My previous, when I heat treat and testing the 20 CV or M390, I don't find the edge that stable, and that's kind of hard to do this. So I'm going to scoop right here though. Right, this is gentle. Ooh, I hear some click. Okay, that is a lot of push right there. Okay. And now I'm going to test again. There, the edge is already twisting every way because I can see it naked eye. Or maybe I can bring it next to the camera. You can see something. I'm interested to see the failure mode, edge failure mode. We test cut the paper for the heck of it and see actually able to continue to slide through without tearing. It managed to sneak through it. Well, okay, just point of note, when a lot of times people say this cut paper like that, right? That is just a good way that you can, the hand quicker than the eye. No, it should be, testing should be like this. Because one, the paper get caught into the, see right now, just the paper just bent. Cut, see now you can see skid. if the divot big enough and the paper got into it, just like a teeth or grab, then you will not tear the paper. But if the divot is smaller than the thickness of the paper, now you can actually skid along. It cuts parts of it and it skid along, and then the next part, that sharp, that will cut the paper. Like so. Like that. So this is lignum vitae out there, and there's the bone here, and the other compound here. And just I'll do thoroughly on this one. I go back and using this edge again, I will cut quick rope again and see what happens. Kind of remind of earlier when I put the rope in it. It just go right through the rope, right? Well, right now they have like a serrated edge. The 7.5 degree precise here. That's why you see the sharpening bevel at fairly wide, and the shininess here is the deburred from the diamond, the 3 micron diamond from the DMT EE dial. Let's see, fold. Anyway, the thickness behind the edge here you can see is a 15 thou. Way up here, about this point right here, and 0.5 millimeter scale. And for the cutting the rope and within softwood, and of course, softwood didn't do anything, and including bamboo. But then when the widow argentine lignum vitae, and you can see the damage, the extent of the damage here along here. I think this thing right here at 10,000 here, maybe this is a little larger here, and maybe this and this are similar in scale. Anyway, and the width of the pork rib bone, you can see here a lot. Both of these things show a lot of deformation. Basically, there's a roll and a ripple, and you can see the extent of the bend before it chip out and fracture. So like for this piece, for example, if you push further and further, it could chip out like that. And so you can see the thing and exhibit that way, because when you have a lot of, in this case, when you have a deflection away from the surface, in this case the bone or lignum vitae wood, and it will just going to, the edge is just very thin. But what I'm looking for is the kind of deformation here. That means at the very small scale level, this is what the edge is capable of doing. The plasticity and this thinness is good. It doesn't roll over. Black would be a lot more ductile steel. But on that note, but if you have something less strength, say steel at 60 Rockwell, then the roll going to be real, and with this edge geometry, the roll going to be substantial. And it will be probably larger than 24/10,000 here, an inch. And of course they weren't able to actually cut because it rolled into a wire. And so, anyway, thanks for watching.